Hello everyone, we are Alec, Hales, and Vinni Rossi, and today we will be discussing the Western and Eastern Snake River Plain geology. Basalt from lava flows are the most commonly found type of rock in the Snake River Plain. The Western Snake River Plain is primarily composed of rhyolite, basalt, and lake sediment from ancient Lake Idaho. There are a number of deep wells that are drilled in the Western Plain that show the interbedded basalt and sediment layers. On the other side of the state, the Eastern Snake River Plain has a similar composition. The Eastern Snake River Plain surface is made up of 95% basaltic flow and is underlain by mafic rock. Silicic volcanic rock is also very common in the Eastern Snake River Plain. However, the main difference between the Western Snake River Plain and the Eastern Snake River Plain is the lack of sediment found in the Eastern Snake River Plain. It is believed that the formation of the Snake River Plain can be explained by the movement of the North American plate over a stationary hotspot, which is now at Yellowstone National Park. Later in the video, Vinny will explain this further. Because of the movement of the North American plate, rocks found in the Snake River Plain go from older to younger as you travel west to east. In the Eastern Plain, the Idavada silicic volcanic rocks range in age from 6.2 million years old to 10 million years old. Large rhyolite domes found in the Eastern Snake River Plain range from zero point 0.3 to 1.5 million years old. While over in the Western Plain, Idavada rhyolotic tuffs that came from buried calderas are roughly 15 to 11 million years old. Most basalt flows in the Snake River Plain were formed between the Pliocene and the Holocene epoch. This means that the younger flows aren't more than a few thousand years old, and the older basaltic flows are about 4 million years old. There are a number of geologic features found throughout the Snake River Plain. I will highlight just a few. There are the three main domes in the Eastern Snake River Plain. These are the Big Butte, Middle Butte, and East Butte. Big Butte rises approximately 2,500 feet from the plain, making it the largest of the domes, as well as the youngest with an age of approximately 300,000 years old. Big Butte and East Butte are rhyolite domes, while Middle Butte is an elevated block of basalt flow that was pushed up through volcanic activity. One other notable spot on the Snake River Plain is Shoshone Falls, which is part of a 6 million year old rhyolite lava flow.
The commonly accepted model for the geologic history of the Snake River Plain is the hotspot origin model. A study done by Pearson Morgan in 1992 suggests that there are three lines of evidence that support this hotspot theory model. The first piece of evidence is the record of silicic volcanism as the result of movement of the North American plate over a stationary mantle plume, also known as a hotspot. The second piece of evidence is the four zones of increasing seismic activity that form the intermountain seismic belt around the current location of hotspot activity. And the third line of evidence is the topographic changes resulting from the passage of North American plate over the hotspot. And due to thermal uplift, the land rose. And as the hotspot moved further to the northeast, the highlands went down due to the cooling of the underlying crust beneath it. Now, the topography of the eastern and western Snake Plain seem to be very similar. In fact, they're actually continuous. However, the geologic makeup of these two plains is actually quite different. As the Continental Divide moved eastward across southern Idaho, rivers south of the Snake River began to flow south and east. And subsidence in the wake of the hotspot movement caused a drop in the base level of the Snake River Plain, which initiated the erosion towards the modern-day Snake River Channel, thus giving us the Snake River Channel. The Snake River Plain provides many natural resources which we use every single day. There are 3 million acres of farmland on the Snake River Plain that are irrigated, with approximately 1/3 being from wells and the remaining 2/3 being from canals. Now, this extensive irrigation system is the primary reason that Idaho has the highest per capita water consumption in the United States. But due to hydraulic and geologic conditions along the Snake River aquifer is divided into two sections, the western and the eastern aquifer. Now let's start with the eastern Snake River Plain. The eastern Snake River Plain aquifer is the only source of drinking water for over 300,000 residents in eastern Idaho. Now, because of this, the Environmental Protection Agency, or EPA, designated it as a sole source aquifer. Now, without this aquifer, the land there would be a complete desert. Now, while the aquifer has provided much for the humans, human activity has also had a tremendous impact on the water balance of the eastern aquifer. About 60% of total recharge of the aquifer is derived from irrigation with surface water. Most groundwater still leaves the aquifer via springs and seepage losses in two major upper basin reaches, although pumping withdrawals continue to contribute significantly to the aquifer's total losses. Now let's move on to the western Snake River Plain. The western Snake River Plain aquifer is used very differently than the eastern. The Treasure Valley contains a complex system of shallow, intermediate, and deep aquifers. Shallow aquifers often supplied water to the rural, domestic, and some irrigation wells. Industrial and some irrigation wells typically draw water from the deeper aquifers. Now, the intermediate aquifers, found in the transition from shallow to deep zones, those provide water for domestic irrigation and municipal uses. Another use of the western and eastern Snake River Plains is the American Harvest vodka. It is made from the water beneath the Snake River Plain. Now, we actually had to try this vodka out just to make sure it was authentic enough, and boy, was it good.